Um, Eric gave a pretty in-depth introduction to the NISAR data, and he mentioned at some stage the Opera project. And in the interest of time, since we will use the Opera data in the current forms in the tutorials quite a bit, so you will get to know the characteristics, how to download those. They are all covered in the notebooks. I will keep this part a little shorter just to give you a brief introduction of what actually Opera is. It stands for the Observational Products for End Users from remote sensing analysis. So it's this thing that, as Eric mentioned, it is a project at JPL that, at least from the SAR end, started at April 2021. It includes products that are not just, and he talked about that, it is not just level 2 products, but also higher level products. So it's this thing about, it includes surface water extent, surface displacement, and the surface disturbance derived from the Opera project. As far as that goes, it's just not Sentinel-1 data, which is the SAR part, but Sentinel-2 and Landsat-8, which is optical data. So it's this thing about the main point, the take home message over here, that all the Opera products are generated in NISAR format. The main products that we have currently available through Vertex, so they just about got available through Vertex, are two of those types. As they are the co-registered single or complex data, which is something that we will use in the NISAR tutorials later. And there's and Eric mentioned that it's slightly different nomenclature over here. It's the radiometric terrain corrected SAR backscatter data, which is the closest that you probably have is the GCOF data for NISAR there. So the main issue, as I said, is like these are products generated in NISAR format. In its current form, they might not have all the capabilities that NISAR has. So there are some things that are still sort of in the early phases. As Eric mentioned, there's a lot of information in there. So the metadata and the structure is mostly the same, but it might not have the full capabilities, the full width of the products yet. Some of it is generated from simulated data, but the main thing is take home is we're looking at Sentinel-1 data that is in NISAR format. That's sort of the one thing to consider there. So there's not necessarily even a possibility to, because Sentinel-1 does not generates, for example, quad pole data. So there is some limitations to what the data can possibly be, but since Sentinel-1 is single pole and dual pole, at a later stage, I mean, as we progress over time, Opera data will have probably the full capabilities of that. I have, what are we having here? Okay, this is sort of and I have the most part is informational, and this introduction, as I said, the contents will be covered in a number of the tutorials. So I've included a number of QR codes over here that actually allows you to directly go to the websites of Opera, and in this case the Vertex website, where you can directly look at the CSLC. Those are the co-registered SLC images, so everything is in a complex format. However, the data is sort of depends on where you are. If you are in more Arctic areas, you will have polar geographic coordinates. For anything else that is more in the regular moderate latitude regions, you will have images that are provided in UTM coordinates. And since we're talking about singular complex images, they contain both the amplitude and phase information. So if there's anything that you need to do with the phase information, which is directly a question of interferometry, this is what you will need. If there's anything that just requires only the amplitude, you could actually then look at, you know, the RTC. So this is, and I think these couple of those links were actually given by Eric already. So there's a product spec. The product spec is a little bit, there are two parts of it. You have the actual product itself is, you know, in the regular product spec. And there are some static data, which is mostly ancillary information. So that is something like, say, the orbit information, those kind of things that don't really necessarily, I mean, there's some more, I mean, the list of static data is actually a lot longer, and we'll go through those in some detail. Those product specs are not included in everyday granules, but the product specs are then, say, as I mentioned, orbits. Those are actually available not necessarily just for that particular image that you're looking at, but for longer swaths and all that sort of stuff. There is, and that's probably a very useful one, is the visualization guide, because the CSLC data is saved in a particular format, which is actually, we will talk about the HDF5 data formats tomorrow. This is actually saved in a compound format. So it's this thing about there is an amplitude and a phase information that is saved separately. So it is worth looking into the visualization guide if you want to just get an idea about what the visual of, you know, these CSLC data actually is before you, you know, process that stuff. You don't have to, but if you just want to get an idea, a look and feel of, you know, what the data is to offer, I would recommend going through the visualization guide to get, there's an example in there how to get the data displayed in QGIS, so that you have an idea how what the data is covering, and how to at least get an idea about coverage and the type of information that you have within a GIS environment. I mentioned the other product that we have in Vertex. Similar things apply. It is the radar backscatter normalized with respect to topography. Joshua captured that part. So this data is terrain corrected. So the geometry is corrected. So the data is not leaning towards the sensor anymore. So it's in its correct geometry. And at the same time, the brightness or the backscatter is normalized, so that the imagery looks as, say, normal as it can be. Same thing, it's map projected to UTM or polar stereographic coordinates, depends on where you are. And as mentioned before, I think Joshua covered that as well. It's like this data has been corrected using the Copernicus Global 30-meter reference dam. So this is not using the old SRTM dam, but the currently available global Copernicus. Same thing over here is the Opera RTC website and the Vertex website. So it's like the Vertex pod is something we will, I think Alex will cover that in a different tutorial. So, but these are sort of your starting points to get an idea about the data. They are, and I think Eric mentioned that as well, it's like there are additional Opera products. There's the dynamic surface water extend. That is currently, what is currently available is actually the harmonized Landsat Sentinel-2 data sets. This is actually not available from ASF, but from, I believe, the the surface water extent. It is, I think the one is that should be in Podak. But there are plans to make the surface water extent available based on Sentinel-1 data that is planned currently for July 2024. So we don't have the data set yet, but this is the current launch date for that. So if you're waiting for surface water extents based on Sentinel-1, middle of the year is probably your best bet. The surface disturbance is at the moment currently available as derived from optical data, and I believe this is available from the LP deck. But there are links in the material so that you can actually find where the data is. The surface displacement products is something that Eric talked about as well. For Sentinel-1, those are probably available not before October 2024. That's kind of the current state of affairs as far as these additional Opera products go. I think this is probably as far as I want to take it at the moment. This is mostly, as I mentioned, reference material. The take-home message is the Opera products are outside the NISAR product, so it's just, the NISAR mission. They are, for our purposes, as we will use them in tutorials, based off Sentinel-1 data, but come pretty much in the NISAR data format. So they originally come in HDF5. And as time will go by, the products will probably be fully populated, and there are some things at the moment they are not, quite NISAR-like. We'll talk about that at some other stage, but I think I will leave it at that and give it back to Alex.